guys, welcome to my YouTube channel. Today we're going to be talking about basic probability and how to take our basic probability and use it to make predictions. Alright, so to start our lesson today, I'm going to go over everything that's on this side of the board, which matches what's over here. And then after we talk about all this, I'll zoom into my paper and you can see what I've highlighted as important. And then we'll also go through the practice together, and that'll make it easier for you to see the work. All right, so first let's start with our biggest probability basic with what is it? So probability is the chance of what we want happening actually happening compared to the total number of outcomes. So right here I have a little section, probability of wanted. So whatever we're talking about is going to be inside of our parentheses, is going to be equal to the ratio of wanted over total. And remember, we can express that as a fraction, okay? Another word for wanted is favorable, so I made that note on my board. All right, the next thing I want to talk about is how or means add, okay? I know y'all have heard me say this in class 100 million times, and that's because it is so important for you to remember or means you're going to add the two probabilities together, but it is still just one event occurring, okay? Now we're going to move down to our two types of probability. We have theoretical probability, which is what we think will happen. We haven't actually done an experiment, sorry, I can't talk, and we are just taking a guess on what we think will happen based on the object. So looking at our little dice right here, the theoretical probability of rolling a 6 is 1 because there's 1 6 on a total of 6 sides of our dice, okay? Now the experimental probability is what actually happens. It's what we see happen when we do an experiment, okay? Moving into making predictions, this isn't something that we had been able to go over in class yet, so this should be your new material for today. And guess what? It's super easy because I know you know how to solve a proportion. Anytime we are predicting the outcome of an event, we are going to use a proportion. So remember, predict uses proportions, okay? And we're going to set it up like this. Our theoretical probability will be on one side, and on the other side, we're going to use the information that we are given about an experiment, okay? And once we have it set up, we just cross multiply our numbers and divide by our oddball. It's so easy. I know you know how to do this because you have done so well with this all year long. All right, so all I've done on the paper so far is just highlight key terms. If you would like to pause at this section and either take notes on what's been highlighted or highlight them on your own paper, that would be great. All right, moving into the for instance section, I have already completely set up and solved this problem, but let's walk through it together. The question is, how many times can we predict to roll a 5 if we roll the dice 60 times? Right here, we have the word predict, so we automatically know we should be setting up a proportion to solve this problem, okay? And remember, on one side of our equation, we have our theoretical probability. Okay? A lot of y'all will try and get confused and put a 5 on top, but let's think about this. We want a 5. So what is our probability of getting a 5? There is only one 5 on our dice with 6 total sides, okay? So that is where the 1 over 6 comes from, okay? Then we're going to set up a proportion with our theoretical equal to what we are given. We are told that we're going to roll the dice a total of 60 times, okay? This is the information we're given about the experiment, and because it's the total, it goes in the bottom of our proportion, and we know in the spot up top we're going to put our X. Right, so here I have it written out. Theoretical of probability 5 equal to what we are trying to predict, okay? Then we cross multiply. We will do 60 times 1, 60 times 1, which equals 60, and then divided by our oddball right here, 6, which gives us 10, meaning x is 10. Putting this into words, if we roll a dice 60 times, we can predict we'll get the number 5 10 times. All right, moving into some additional practice. I have a picture here of the spinner that we're going to use for numbers 1, 2, and 3. Let's start with number 1 together. If we spin a spinner 72 times, how many times should we land on 3? Okay, this one doesn't explicitly say that we're predicting, but because it's asking how many times something should happen, that is a prediction. That means we are trying to predict, okay? We also know that we're looking for the theoretical probability of landing on 3, so let's start there. What is our theoretical probability of landing on a 3 on this spinner? We have 1, 3 out of a total of 8 sections, okay? Then we are going to set that equal to, we are spinning the spinner a total of 72 times. That is our total, so it goes on the bottom, and x is going to fill in our last spot. Okay, so to cross multiply and divide, we do 72 times 1, which will equal 72. And then we divide by our oddball right here, which is 8. Now, oh my goodness, why did I write 78? That should be a 72. See, even math teachers make mistakes. What do I do without y'all to call me out? Divided by 8. 72 divided by 8 is going to equal 9, okay? Which means x equals 9. So what does that mean for the problem? That means if we spin our spinner 72 times, we should land on 3 9 times, okay? Moving on to number 2. If we spin the spinner 48 times, how many times can we expect to land on a 1 or 6? Again, we have a different vocabulary term right here, meaning predict, okay? It's asking how many times can we expect, okay? This is also key for predictions. All right, to land on a 1 or 6. So when I underline this, I'm also going to put a little plus sign because or means add. And we are not adding 1 and 6 to get 7. We're adding the probability of a 1 and the probability of a 6. Okay? So that means probability of 1 and 6 gives us a total of 2 out of 8. On this side, we put our theoretical, and we're going to set that equal to what we are given about our experiment. And we are told we're spinning 48 times as our total, and x fills in our last spot. Okay? Then we just cross multiply and divide. So we're going to do 48 times 2. 48 times 2, we get 96, right? Then we do 96 divided by our oddball here. So 96 divided by 8, that will give us 12, which means x equals 12. So in terms of the problem, if we spin this spinner 48 times, we should expect a 1 or a 6 12 times. All right, at this point, I would love for you to pause and attempt to do number 3 by yourself, okay? And after you've done it, go ahead and press play again, and then I'll work it out with you. All right, number 3 is asking, if we spin a spinner 112 times, how many times can we predict we will land on an odd number? Okay, Here's our key word, straight up predict for us this time. First, we have to set up our proportion. And on this side, we're going to put our theoretical probability of an odd number. Remember, those are our numbers 1, 3, 5, 7. It's all those numbers that are not divisible by 2. Okay? So looking at that, that gives us 4 out of 8 as our theoretical probability, which we could also reduce to 1/2 if we wanted. Okay? On the other side, we are spinning the spinner a total of 112 times. And then we fill in our X with our top. So first we're going to cross multiply. So we do 112 times 4, which gives us 448. Okay? And then we divide by our oddball. So then divide by 8. Okay? And 448 divided by 8 should give us 56. So X equals 56. In terms of our problem, this is telling us if we spin our spinner 112 times, we should expect to land on an odd number 56 times. That's the end of our video lesson today. I hope it was helpful. If you have any more questions, please message me on It's Learning and I'll get back to you as soon as possible. Y'all have a great day and know that I miss you. Bye.